As you start deploying more sophisticated applications in Azure, you'll often find that a single container isn't enough. That's where container groups come in. In Azure container instances, the container group is the top level deployment unit. It's a collection of containers that get deployed together on the same underlying host. When you group containers this way, they share the same life cycle. Resources like CPU and memory, a local network, and even storage volumes. You can think of a container group like a Kubernetes pod. Just like a pod, it can hold one or more containers that work together to perform a single task. These containers are co-scheduled, meaning they start together and stop together, and can easily communicate using local hosts because they share a private network namespace. For example, if one container is running a web server and another is responsible for pulling content from a database or Git repository, they can talk directly over the local network within the same group. That kind of architecture gives you flexibility without the overhead of a full orchestrator like Kubernetes. When you create a container group, Azure adds up the total resource request from each container. That means if one container requests one vCPU and 1.5 gigabytes of memory, and another requests 0.5 vCPU and 1 gigabyte of memory, your container group will be scheduled with 1.5 vCPUs and 2.5 gigabytes of memory. This is great because each container can be optimized independently, yet they run as a single coordinated unit. You have a couple of options when it comes to deployment. ARM template. If you are deploying container groups alongside other Azure services like storage or networking, you should use an Azure Resource Manager, ARM template. This gives you a full infrastructure as code setup. YAML file. If you only want to deploy containers and keep things simple, a YAML file is the better choice. It's concise and easy to read, ideal for quick iterations. When your container group needs to be reachable from the outside world, Azure gives it a single public IP address with a DNS label. All containers in the group share this IP and DNS name, and they can listen on one or more shared ports. But here's something important to remember. Port mapping is not supported. Since the containers share a single network namespace, each container must listen on a unique port within the group. For example, one container can listen on port 80 for HTTP traffic, while another listens on port 1433 for SQL communication. And once you delete the container group, the associated IP address and DNS name are released, so they're no longer available. You can also mount Azure file shares to each container. Let's say you have two containers. One mounts a file share to serve app content, and another mounts a different share to manage logging or data output. Each container can access its volume independently while still working together inside the same group. So, when should you use multi-container groups? Let's unpack some powerful scenarios. For web app updates, you can have one container serve your web app while another container continuously pulls updated content from source control. This lets your app stay fresh without needing to redeploy the whole stack. For log collection, one container runs the app while a second container collects logs and metrics, sending them to long-term storage or a monitoring dashboard. For app monitoring, a dedicated container can be responsible for sending health checks to your main app container. If something goes wrong, it can trigger alerts automatically. And for front-end and back-end architecture, you can run a front-end container that serves your UI and a back-end container that processes logic or data queries, all inside a single group, all within the same lifecycle. So what's your key takeaway? By using container groups in Azure container instances, you're able to architect modular, scalable, and efficient microservices. without having to deploy an entire orchestrator. You split responsibilities across containers, assign resources intelligently, and keep everything tightly integrated, all whilst reducing operational complexity. Next time you are thinking about how to structure a multi-tier app or support background processes, consider grouping your containers. It's simple, powerful, and designed for the cloud.